Welcome. Now we have 2022 firmly in our rear view mirror. It's a good opportunity to take a look back and see how solar cycle 25 is progressing, especially as January of 2023 was the most active month of solar cycle 25 so far, and also equaled or exceeded any month during solar cycle 24. So it seems we are well up the rise phase of solar cycle 25. The question now is, how long will that rise phase last and how big will it get? Now I'm going to show you today some analyses that I've done that you'll see nowhere else on YouTube or anywhere else for that matter, because these are data that I've taken from various sources and analyzed in my own way. This is something that the pretend solar physicists on YouTube just don't do and can't do. So let's take a look at what solar cycle 25 is doing at the moment and what it's likely to do in the coming years. Well, let's take a look at the summary of what we're going to talk about today. Solar activity is definitely on the rise. We had record daily sunspot numbers in the last month, record monthly average sunspot number. We had 3 X flares, 41 M flares, and 350 C flares, plus 168 coronal mass ejections. And that's a lower limit because there are 3 days of missing data from LASCO that we may never know how many coronal mass ejections occurred during that time. Well, let's first take a look at the most fundamental quantity associated with solar activity, and that is the sunspot number. We have 3 different renditions of sunspot numbers here. In yellow, we have the daily sunspot number, which you can see is highly variable. In blue, we have the monthly average sunspot number over the last 13 years. That takes some of the variability out of the thing, but still it's quite a few peaks and valleys there. Now the red curve here is what's called the smooth sunspot number, and that's the parameter that we use to give the measurements of a solar cycle. How big and when maximum is, and how small and when minimum is. You get the smooth sunspot number by taking the monthly average sunspot numbers and averaging them over a 13-month period. Now the thing to note is that January of 2023, the last point on this curve, is higher than or at least equal to all the previous months of solar cycle 25 and solar cycle 24. And you probably have to go back 20 years or more to find a monthly sunspot number that is significantly bigger than January of 2023. So we had quite a major leap in sunspot number in these last couple of months. Now the question is, how much further up is it going to go and when will it peak? And that's what we're going to be looking at today. As I mentioned before, the smooth sunspot number is a very important parameter. So I've plotted that out from the beginning of solar cycle in January of 2020 to the current time. The thing to notice here is that the rate of increase seems to be accelerating. In fact, the last jump in the smooth sunspot number was the largest jump so far this cycle. Will that trend likely continue? I think at least for a while, but the frenzied pace may slacken off a bit in the next couple of months. So let's actually take a look at some of the data. This is a movie of the sunspots for the last month, taken with the Solar Dynamics Observatory HMI instrument. About 5 years ago, NASA and NOAA got together and predicted what they thought solar cycle 25 would be like. That's the red curve on here. And you can see it's slightly larger than solar cycle 24, but not significantly so. The diamonds on here, joined by the black line, actually are the real data, and you can see that this is outperforming the model by a very significant factor, like about a factor of 2. If we have the same timing for this cycle, i.e. peak in 2025, and this difference was continued, we can actually estimate how big solar cycle 25 would be. From the sunspot number, it would imply that there's a maximum of around about 270 for the cycle if it peaks in 2025 and carries on exceeding the model by this sort of rate. Now, I think that's unlikely, but nonetheless, it's the possibility. If you look at the 10.7 centimeter radio flux, which is also a measure of solar activity, that too is outperforming the model by quite a significant margin, and that would imply an even higher sunspot maximum of 316. So I think that's even more unlikely, but nonetheless, it's a possibility with those assumptions. So either what's likely to happen is we'll have an earlier maximum than the committee predicted, or this frenzied pace of solar cycle 25 will not continue for much longer. Here's another measure of solar activity that you won't see from many other sources, and that is the area of sunspots on the sun as a function of time. What I've done here is I've taken the area of the sunspots on the sun every given day and added them up over one rotation, and you get this pattern from it. You notice that, first of all, January of 2023 is way higher than the rest, which is consistent with the sunspot numbers. But another thing to notice here is these activities come in bursts. It's like a burst of sunspot activity, then there's a period of 2 or 3 months while it rests and resets, and then comes back with a bigger burst. And so that pattern has continued since the very beginning of the cycle. So you would say that, yes, we've just had our burst, it's beginning to come down now. In February and March, possibly even into April, those sunspot numbers will be a bit lower. April to May, it will start going back up again, and we'll probably get another peak in May or June, which could be as big, if not bigger, than the one we just had. So let's take a look at the area of the magnetic fields. And you do this using magnetogram. That's from the Solar Dynamics Observatory HMI instrument again. So this again is one rotation movie. An interesting thing to look at is the latitudinal dependence of sunspots as the cycle progresses. Here we have several cycles over the last 150 years, and you can see that the sunspots start at high latitudes and drift towards the equator. Now I've marked in here the dates of solar minimum, and you can see that that represents when the sunspots reach the equator. That represents the end of one cycle and heralds the beginning of the next. So here is that variation for solar cycle 25. Again, this is something that I've done and you won't see anywhere else. In the top we have the northern hemisphere, and you can see that it started off around about the mid-20s and has declined over the first 3 years of the cycle to something just under 20. In the south, pretty much the same picture, but starting at -20 rather than +20. You can see the rate between these two is very similar. Of course, if you take where we are now and divide that by this rate, you get a date when you reach 0, which would be when you get solar minimum. So what does that imply? The solar minimum in the northern hemisphere would be in August of 2029, and in the southern hemisphere it would be in March of 2030. But that would give us an approximate average of the two of the end of 2029, beginning of 2030 for the date of minimum. And you can actually use that date of minimum and the ratio of the rise phase to the decay phase to get a date of solar maximum. For some unknown reason, people like to consider spotless days. Nonetheless, this is what you get. You can see obviously at the beginning of the cycle, out of the 28 days, a large number of times we had spotless days for the whole rotation. But as time has gone by, in the first 2 years of the cycle, the numbers of spotless days has basically dropped to 0. The total number of spotless days is just over a couple of hundred at the moment. Now you'll often see huge numbers like 800 or whatever, and people saying, well, this means that we're in a grand solar minimum. What they're doing is they're taking the spotless days from the decay of solar cycle 24 and adding those to the spotless days in solar cycle 25. We have had over a year without a spotless day, and I think that's going to continue for quite some time yet. The solar atmosphere is in layers. As you go up from the surface of the sun, the layers get progressively hotter. The first region is called the transition region, the transition from the solar surface, the photosphere, up into the corona. And that's visible from a line in the AIA instrument on Solar Dynamics Observatory called the helium-2 304 line. It's a very strong line and it allows you to see the transition region and temperatures up to 50,000 degrees Kelvin. So let's take a 28-day look at what the sun was doing in January of 2023. That most people don't bother with is the 1700 angstrom continuum movie. And that allows you to see simultaneously sunspots. The bright areas around sunspots called plage and flares. You'll see flares as little flashes near the sunspots. So this enables you to see where the flares are with respect to the sunspots, which is very useful at times. Well, let's see how that relates to the corona. This is the lowest coronal line we have, which is an iron 9 line at 171 angstroms, and has a temperature of about 630,000 degrees Kelvin, and about 10 times hotter than the helium 304. One of the interesting lines that the AIA instrument looks at is the 193 line. And you can see this dark area in the middle of the sun on the left-hand image. That's a coronal hole. A coronal hole is an area of open magnetic field where the solar wind escapes into interplanetary space and can hit the Earth and cause things like geomagnetic storms. But the coronal hole I'm interested particularly here is the polar coronal holes. And you can see them here if you look carefully. At the northern part here, you see that line of prominences. That's the southern edge of the northern polar coronal hole. At the moment, the B angle is very negative. In fact, about as negative as it's going to get. So the northern pole is tilted away from us, and the southern pole is tilted towards. So we're getting a very poor view of the northern polar coronal hole, but a good view of the southern coronal hole, and that's there. And you can see this dark line that stretches from limb to limb there. That's the polar crown filament that demarks the boundary between the polar regions and the rest of the corona in the southern hemisphere. And that effectively shows you how big the coronal hole is at the poles. So let's take a look at the equivalent magnetogram at the same time. And I'm going to blank out the middle section because that's just confusing. Now take a look at the northern polar coronal, which we don't get a very good view of. Does that look lighter or darker on average than the southern polar coronal hole? To my way of thinking, it looks a lot lighter. So that means that the southern polar coronal hole is more negative. So the negative polarity there. Now what happens is, as time goes by, that area cancels more and more, and that area will shrink. And when it shrinks to zero, you're pretty close to solar maximum. So how fast is this polar coronal hole shrinking? We'll take a look at the southern polar coronal hole because that's the best one we've got at the moment. So here we are. On the left we have the polar coronal hole in February of 2022, the beginning of February 2022. And you can see that the angle of that southern polar coronal hole is about 64 degrees. In February of 2023, just a couple of days ago, that angle is now 50 degrees. So you can see how fast that's shrunk 16 degrees in just a year. You can then work out how long that will take you to solar maximum to get to zero there. And that would be January of 2026. But that's an upper limit. Now, why is that an upper limit? Well, as this solar cycle progresses, more and more flux emerges in the southern hemisphere and will be transported to the pole and cancel it quicker and quicker and quicker. So the longest it could last is January 2026. It probably could be somewhere in 2025 or perhaps even earlier. So let's take a look at the evolution of coronal holes as seen by the AIA instrument. This is the so-called quiet corona. It doesn't look all that quiet to me. The temperature is about 1.2 million degrees. We can do another comparison here between solar cycle 24 shown in blue and solar cycle 25 shown in red. Noah counts the large, most prominent sunspot regions, and so far in solar cycle 25, that's outpacing solar cycle 24 by about 12%. If that was reflected in the value of the solar maximum, would give us a solar maximum of about 130. Now I do a similar count for regions that produce any sunspot, not just the major ones. And you can see here again, the rate of the emergence of these regions is accelerating. In January of 2022, we had 77 such regions emerge. The previous year, we had about half as many emerge. So this process is continuing to accelerate. Again, the question is, how long will it continue to accelerate before it tops off and turns back down again? You can best see regions on the Sun using the 335 angstrom iron 16 channel. They appear as bright centers or active regions. That's at a temperature about 2.5 million degrees. X-ray flares come in three categories: C flares, which are the smallest of the flares, M flares, which are moderate to important flares, and the X flares, which are very, very big flares. If you base the relative activity of solar cycle 24, shown in blue, and solar cycle 25, shown in red, solar cycle 25 is outpacing solar cycle 24 by a margin of 2 to 1, which would imply that we have a solar maximum of about 229 if this reflects the eventual size of the cycle. If we use M flares rather than C flares, the ratio is 78% more in solar cycle 25 than solar cycle 24, which would imply a solar maximum of about 206. Now the flares that everybody loves to look at, these are called X flares. They are 100 times larger than the C flares. This is a logarithmic category. And they're outpacing solar cycle 24 by about 50%. Now the warning here is these are very small numbers. And so you're dealing with statistics of small numbers, and the amount of reliance you can put on this sort of ratio is very, very poor. As I said, there were 3 X flares, so let's take a look at those individual X flares. The first flare was an X 1.2 flare on the 6th of January of 2023 at O's 57 UT. It was on the southeast limb. That made it the 6th largest flare of solar cycle 25 so far. It was from sunspot region numbered AR 3182. I'm going to show you a 6-hour movie of each one of these flares. And interesting enough, it did not produce a coronal mass ejection. The second flare in January was an X 1.9. It was on the 9th of January at 1854 UT. It was also on the southeast limb. It's the second largest flare of solar cycle 24 so far. It was from sunspot region AR 3184. And again, we can show you a 6-hour movie. It did produce a very weak coronal mass ejection, shown here with the blue arrow. The third X flare we saw in January is on the 10th of January at 22:47. It was on the northeast limb this time. It's the 10th largest flare of solar cycle 25 so far. It was in Sunspot region 3186 and did produce a weak CME rather similar to the previous flare. Now the best channel to see flares in is the iron 20 flare channel at 131 angstroms from the AIA instrument. It has a temperature of about 10 million degrees Kelvin. Another measure of solar activity are coronal mass ejections, and we can get those values from the LASCO catalog. The solar cycle 25 is outpacing solar cycle 24 by about 28%, which, if propagated through to reflect solar maximum, it would predict a high value of 148. So let's take a look at the coronal mass ejections produced during January of 2023 using the SOHO LASCO C2 instrument. So let's summarize all these predictions. I've put them in here in a table. The first column is the peak value. The second column is the inferred date of solar maximum, or the assumed date of solar maximum, and the solar minimum date on those parameters that produced an estimate for solar minimum. Then at the bottom we have the average. Now the first line I've not talked about as yet. This was my prediction back in 2019 based on a mathematical process called regression to the mean. When you have a large sample of measurements of a thing and you can derive an average from it, if you get a below average reading, the high probability is that the next reading will be higher. If you get a high value, the probability is the next value will be lower. Now the solar cycles, about 75% of solar cycles follow this rule. So I predicted based on that we would have a maximum of 165, and it would be sometime in mid-2024. The solar minimum date would therefore be late 2030. The various sunspot models from the SIDC predicted a peak of about 150 or somewhat higher. The other model produced was 120. Sunspot numbers, as I said, produced 270. The 10.7 centimeter radio flux, 315, which I think both of those are unlikely. Sunspot regions predicted 130. C flares 229, M flares 206, X flares 174, and coronal mass ejections 149. So you see there's a big range of values here. And the average came out at about 191, which is slightly above average, but with a very large uncertainty on it. The inferred date of solar maximum would be spring of 2020. So we have another 15 months or so until solar maximum. And the couple of times we've been able to estimate when the next solar minimum would be, and that averages out like summer of 2030. So this would be just a slightly over a 10-year solar cycle. So what comes next? Well, let's revert back to this SIDC image. We can say that the sunspot number can continue to go up. It can go sideways, stay about the same for a while, or drop back down. Now, based on those areas of sunspots that showed these bursts of activity, it would imply that the next couple of months, the sunspot number is going to be down slightly. So we'll take a look and see if that happens. And you can sort of see what happened in solar cycle 24. There was an early peak, which this might be equivalent to. Then the sunspot number dropped off for actually a couple of years. And then we had a secondary peak in 2014, April of 2014, which turned out to be the eventual maximum. Now, each cycle has several peaks to it. Some have just two, many have three or four. So we don't know how many peaks solar cycle 25 is going to have, when they're going to occur, and how big they're going to be. So it's going to be a bit of a bumpy ride for the next 4 or 5 years. So this is part of the excitement of observing the sun over these coming years. So what conclusions can we draw from all of this? The sun is still in the rise phase of solar cycle 25 and is likely to be there for at least a year or two. Various methods give different results for the predicted solar maximum. It's likely to be significantly higher than solar cycle 24. There was a very large jump in sunspot number in December of 2022 and January of 2023, but that rise is unlikely to be maintained in February and March. This may be just the first peak of activity. How far will it go down? How far will it come back when the next peaks come along? We have to wait and see. So this is going to be fun. So thank you for watching. Until next time, stay safe and goodbye.